Welcome back to Talk Tensors, the show where we take apart machine learning papers and, offer our take on them.
Right.
And today, we're going to be diving into OmniRGPT, unifying image and video region-level understanding via token marks.
Yeah, this paper really caught my eye.
Oh, yeah?
Yeah, it tackles this challenge that's been kind of plaguing the field for a while.
Okay.
It's the whole, how can AI actually understand specific regions in images and videos?
Right, not just like label objects.
Yeah, exactly.
It's one thing for an AI to say, there's a cat.
Right.
But it's another to understand what's happening in specific areas. Like, why is that cat looking at that coffee cup or whatever, you know?
Exactly. And that's where OmniRGPT steps in, right? It introduces this really cool method for actually pinpointing and like comprehending those regions. And it does it with some impressive accuracy.
Really?
Yeah, think of it like, imagine if you gave the AI a set of highlighters.
Okay.
And they could use those to mark the most important parts of an image or video.
Oh, that's a great way to put it. So it's not just about identifying objects anymore. It's about understanding the context and actions within specific areas.
Exactly.
But why is region-level understanding so tricky, especially when it comes to videos?
Well, for starters, videos are they're so dynamic.
Right.
Objects are always moving and changing how they look.
Yeah.
They're interacting with each other.
Yeah.
So how do you teach an AI to actually keep track of what is what amidst all that chaos?
Right. It's like, and what about the sheer amount of data in a video?
Oh, yeah. You're hitting on another big challenge, scalability.
Right.
Traditional methods.
Yeah.
They often analyze these videos frame by frame.
Yeah.
Which just creates this enormous amount of data.
Yeah, it seems incredibly slow and inefficient.
Yeah, for sure.
So OmniRGPT has to overcome not just the complexity of understanding those moving regions, but also just the massive amount of information that it's dealing with.
Yeah.
So what are some of the ways that researchers have tried to deal with this before?
Well, some earlier methods, they tried to rely on this thing called textual coordinates.
Okay.
Essentially, they tried to define regions by feeding the AI like numbers that represented the location of each object in each frame.
Oh, I see.
Yeah.
So it's kind of like trying to understand a movie by just looking at like a spreadsheet of coordinates for each scene.
Exactly.
Yeah, you totally miss the nuance and richness of actually like seeing what's happening.
You got it.
Yeah.
It's a very limited way to understand that visual information.
Right.
So then researchers started to explore regions of interest or ROI features.
Okay.
Which, it was a step forward.
So instead of just giving the AI coordinates, they were giving them more detailed visual information from those specific areas.
Exactly. Okay.
So methods like Region GPT and GPT-4 ROI, they extracted those features and kind of embedded them into the language prompts, giving the AI a lot more to work with.
That makes sense.
But, as we touched on earlier, this approach kind of ran into a wall with video.
Right, the whole temporal drift problem.
Exactly. As objects change, those extracted features would become inconsistent.
Yeah.
Making it hard for the AI to keep a good understanding of what's happening.
Yeah.
So how did OmniRGPT address this?
This is where the really clever part comes in. They introduced token marks.
Okay.
So instead of relying on those visual features, they just assign these predefined tokens to the regions. It's almost like color coding them.
Oh.
So instead of trying to describe every visual detail of a cat, let's say, in every frame, you just mark the cat region with a specific color, so to speak. That means cat.
So it's like giving the AI a simpler, more consistent way to represent a region.
Exactly.
Without getting lost in the details. And that color would stay the same across all frames.
Exactly. That's how they tackle that temporal drift problem.
Wow, that's really clever.
And because you're using a limited set of these tokens, it's way more scalable for video analysis than trying to process like full-blown visual features for every single frame.
That makes a lot of sense. So how does OmniRGPT connect these token marks to the language prompts? I'm picturing this as a sort of canvas where the tokens are like paints marking out those regions of interest.
You're right on the money.
Really?
Yeah, the paper actually uses a very similar analogy.
Oh, cool.
Imagine the visual tokens as your canvas and your token marks as your paints, your colors, and you paint the target regions with their assigned colors. So you're basically directly embedding that information into the visual input.
Okay.
And then the language model sees these colored regions and learns to associate them with the text prompts.
I'm starting to see how this could completely change how AI understands video.
Yeah.
But we haven't even talked about how it handles the fact that those regions are moving and changing positions from one frame to the next. How does it keep up with all that?
Right, right. Right. So that's where the temporal region guide head comes in.
Okay.
It's specifically designed for video.
How does it work?
Well, imagine you're teaching the AI to kind of predict where those colored regions will move.
Just based on their position in the first frame.
Okay.
So it guides the model to keep focusing on the right regions
Right.
as they move across frames, even if only that first frame actually has those, the marked region.
Oh, so it's not like it needs to recolor them in every frame.
No, exactly. Super efficient.
That's really cool.
And here's the other cool thing. This temporal region guide head, it only works during training.
Oh.
So it's not used when the AI is actually analyzing a video.
So it doesn't add any extra processing time?
No, not at all.
That's clever.
So you get the power without the slowdown.
Now, to train a model this good, you'd need a really good data set, right?
Oh, absolutely. That's where RedV300K comes in.
Okay.
It's this massive new data set that they created specifically for OmniRGPT.
What makes it so special? I mean, there were already data sets for this sort of thing, right?
Yeah, there were, but they often fell short in one of two ways. Either they just didn't have enough videos, or the descriptions just weren't detailed enough.
Oh, I see. It's like trying to teach someone about the whole world with, just a couple of pictures.
Right, that makes sense.
Or descriptions that just say cat instead of telling you what the cat's doing, you know, how it's interacting with the environment.
Right, so RegVA300K has way more data, and it's a lot more detailed.
Exactly. It's got a whopping 98,000 unique videos.
Wow.
And it's sourced from like 10 different data sets, so you've got this huge range of scenarios and actions.
So it's not just the quantity, it's the quality too.
Yeah, but the real game changer is how they got the descriptions.
Did they have people write them all out?
You'd think so, right?
Yeah.
Be a huge task.
Yeah.
But they actually used GPT-4.
What? To generate the descriptions?
Yeah, they used GPT-4 to automatically generate these really detailed descriptions for each video.
So they're using AI to train AI.
Exactly.
That's wild. So how did OmniRGPT actually perform when they trained it on this data set?
The results are pretty amazing. It hits state-of-the-art performance on a bunch of tasks, both for images and videos.
Really?
It even beat methods that were made specifically for images.
That's impressive.
Which is crazy considering OmniRGPT is supposed to handle both.
Right.
But it goes beyond just general performance, It also did really well on something called region-level captioning.
Region-level captioning. What's that?
It's like, imagine being able to describe exactly what's happening in a specific part of a video.
Okay.
Not just saying there's a cat, but saying, the cat is playing with a toy mouse under the table.
Oh, so it's really understanding what's going on, not just labeling.
Exactly. And OmniRGPT aced it.
That's incredible. I mean, it's one thing to identify those regions, but to actually describe what's happening in detail, that's a big step.
Huge step.
But, we should also talk about limitations.
Right. No approach is perfect.
Yeah, what did the researchers say?
Well, one thing they pointed out was that even though OmniRGPT can deal with multiple frames the way it's currently set up, it only uses 4 frames as input.
Oh, okay.
So it might not be enough to really get the whole picture, especially for longer videos with lots of complicated stuff happening.
Right, like it's a long way from a few seconds of video to a whole movie.
Exactly.
So scaling it up to those longer videos, that's a big challenge for the future.
Absolutely. Another limitation they talked about was how the model encodes the visual information.
Okay.
Right now, it uses this frame-independent approach, which basically means it doesn't explicitly say how those frames are connected in time.
So it can track those colored regions,
Yeah.
but it might miss the finer points of how they're moving and interacting over time.
Exactly.
Like if a region is getting closer to another one, or if their relationship is changing.
Yeah, stuff like that.
So there's definitely room for improvement.
Yeah, for sure.
But even so, this token mark approach is really exciting.
Oh, for sure.
Yeah, this whole idea of using these token marks, it just seems like it could go so much further.
Oh, absolutely. It's got everyone buzzing. The paper even talks about some really cool stuff for the future.
Like what? What caught your eye?
Well, one thing was using token marks to actually predict what's going to happen next in a video.
So instead of just understanding what's happening right now, the AI could use its knowledge to anticipate what's coming.
Exactly. Like imagine the AI sees a colored region for a ball moving towards a window, right? It understands those regions, so it could predict that the window's about to break.
Wow, that's amazing.
And it's not just about physical stuff. Think about social interactions.
Okay.
The AI could, look at facial expressions, body language, all represented by those token marks,
Right.
and then predict how a conversation might go or if things are going to get, heated.
That's incredible. You could use that in psychology, sociology, even marketing.
Yeah, totally.
So prediction is one thing, but what about real-time interaction?
Oh, yeah, that's a big one.
Like you're watching a video and you could just highlight something and the AI tells you about it.
Exactly. You're watching a nature documentary, you highlight a bird, boom, the AI tells you what kind it is, where it lives, what it does, even points out where else it shows up in the video.
That would be amazing, like having an expert right there with you.
And think about education, like a surgeon using it during an operation.
Yeah, or a mechanic fixing a car.
Exactly. The possibilities are huge.
This is all really cool, but, we've been talking about highlighting pretty concrete things, cats, balls, windows. What if we could use those tokens for, I don't know, more abstract ideas?
That's a really interesting thought. Like, right now, it's all about objects.
Right.
But what if you could have tokens for, emotions, relationships, even ideas?
Yeah, like the AI could tell not just that there are two people there, but that they're having an argument or that they're really happy.
Yeah, that would take things to a whole new level.
It could change how we analyze everything from social media to, I don't know, political speeches, even art.
It's really mind-blowing to think about.
Well, this has been a fantastic deep dive. OmniRGPT and its token marks. It's a huge step forward in how AI understands what it sees, and the potential is just massive.
It really shows how these new ideas in machine learning can open up so many doors. I can't wait to see what happens next with this technology.
Thanks for joining us on Talk Tensors. And until next time, keep exploring, keep asking questions, and keep pushing the limits of what AI can do.